Okay, we've talked about factoring the difference of squares, and now let's talk about the difference of cubes. Make sure I've got my pen right. Okay, so factoring cubes. Now, you will see at the top of the page that they have given you like formulas to memorize. I want to stay away for as much as we can from having to memorize anything, and so I have a cutesy way of remembering how to factor the sum or difference of cubes. Notice that unlike squares, we can do the sum or the difference. So the sign in the middle does not matter on cubes, just on those perfect squares that we did. You have to worry about there being a subtraction sign. So when we go to do cubes, we are going to need to know that we're going to have a binomial parentheses, which is going to have 2 terms in it, and then a trinomial parentheses, which is going to have 3 terms in it. Okay? And when we do these, we're going to put the bases, I call the base of each one, meaning the cube root. I'll write that, cube root, in the first parentheses. Now in the second parentheses, we're going to work off the first one, and we're going to do something called square multiply square. That's going to fill in the blanks in the second one. And then we're going to do something called SOAP to clean up the signs. In the first one, we're going to do the same sign as the original problem. Then the next sign is going to be opposite the sign. So if I wrote a plus at the beginning, I'd write a minus because that's opposite. And then the last sign is always positive, because when we are putting our signs in to this perfect cube, when we're putting our signs in, we're cleaning it up. So we're using SOAP to clean it up, SOAP for our signs. So an acronym SOAP stands for, and I tell you this, I'm very excited because before I started using this workbook, I had not heard anybody else talk about using SOAP, and I was so very excited when I saw that they have SOAP in there. So it's just one of those little things that I got excited about. With respect to factoring, so that means our signs. That's going to help us remember our signs. All right, so let's look at an example. First of all, you need to know what cubes are. So we're going to have, let me see, let's just make, on the next page, you're going to have a little list of cubes, but I'm just going to make a little list out here. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. And 64 is special because it's also a perfect square, so you have to pay attention whether we're doing perfect squares or perfect cubes. 5 cubed is going to give me 125. We'll go, that's as far as we'll go. And then for x cubed, you'd have an x cubed. You could have an x to the 6th, powers of 3, x to the 9th. Powers of 3 would be your perfect cubes as far as your variables go. So if you want to, first of all, we're going to look and we're going to see, do we have the sum of cubes? Do we have the difference of cubes, or we could have neither? So here I've got x cubed and 64. I've got an x cubed. I see 64 on here. This is cubes. And it's the difference because I see a sign of a minus sign in between them. X cubed plus 1. 1 is always a perfect square, perfect cube, anything. And I have an x cubed, so this is the sum of cubes. X cubed minus 16. I've got an x cubed, but this 16, I don't see it anywhere on my number list. So this one is neither. It's not a perfect cube to be able to factor. X to the 4th plus 8. I see an 8. The 8 works, but the x to the 4th is not a perfect cube. So this one is also neither. So both of them have to be perfect cubes. So here's how we factor. And so just if you want to watch the first time and then pause the video and write down what I wrote down, just so you can kind of let it sink in. If I've got x cubed plus 8, first of all, you always look for a GCF. There's not a GCF. I look to see if I have how many terms, so 2 terms. I now have 2 questions to ask myself, perfect squares or perfect cubes. The x cubed gives me a clue to look for cubes. So 8 is a perfect cube because it's 2 times 2 times 2. So you make a binomial parentheses, a trinomial parentheses. So in the binomial parentheses goes our cube roots, our bases, x and a 2. Okay, and I got those from my list over here. So then we're going to square, multiply, square to get the second parentheses. Now what that means is that I'm going to take the first term, x, and I'm going to square it. So that gives me x squared. I'm going to multiply the two terms together for my binomial. X times 2, that gives me 2x. I'm going to write the 2 first. And then I'm going to square the second term in my binomial. 2 squared gives me 4. So now I clean up with my signs. Same sign is a plus. Opposite sign would be a minus. Always positive would be a plus. And there we go. We just factored that cube. So they're not too bad. Again, I don't like to memorize. I think if you can do square, multiply, square, you can figure out the numbers and then SOAP to clean it up. Alright, 64t cubed plus 1. 64 is 4 times 4 times 4. T cubed is t times t times t. 1 is 1 times 1 times 1. I can't take a GCF. I have two terms. They're the sum of cubes. So, binomial, trinomial. Again, be careful with 64 because the cube root of 64 is 4, and then I have a t, and then the cube root of 1 is 1. So now I'm going to square, multiply, square. So I'm going to take 4t and I'm going to square it. You've got to square the 4 and the t, so that would give me 16t squared. You're going to multiply these two together. 4t times 1 gives me 4t. You're going to square the last term, which is a 1 this time, so 1 squared is 1. Then we do same sign. We had a plus in the original problem. Opposite gives me minus. Always positive gives me a plus. Alright, moving right along. 8m cubed plus 27. I can't take out a greatest common factor. I'd look for that first, but there's no factors in 8 that go into 27. I have two terms. I see an m cubed, so I check to see 8 is a perfect cube, 27 is a perfect cube. So go to my binomial and my trinomial. 8 is 2 times 2 times 2, so 2m. 27 is 3 times 3 times 3. So now square, multiply, square. So I'm going to square 2m. So don't forget you have to square the 2 as well. So that gives me 4, because 2 times 2 is 4. M squared. Multiply them together. 2m times 3 gives me 6m. And then 3 squared. 3 times 3 gives me 9. Same sign is a plus. Opposite sign is a minus. Always positive is a plus. There we go. Now, something that I haven't really talked about, the directions say factor completely, and so when I've come down here and I've made my parentheses, I haven't really talked about this second parentheses has a 4m squared. Normally, I would have you check that to make sure it factors, but I don't know that I've even had a case ever where the trinomial in a perfect cube would factor. So on these on these cubes, your trinomial is not going to factor. It's good just leaving it just like it is, and so that should help you out. I'm going to work this fraction one down here just because I think that might help. I don't know why they have this one here, so I'm just going to kind of mark it out. But I'm going to do this fraction one just because we might need to do a fraction. So t cubed is t times t times t. 1 over 125. Remember, 5 cubed was 125. So 1 over 125 would be 1/5. That's a 1. Alright, and then square, multiply, square. See, these are not too bad with the fractions because I'm not having to add or subtract. So square the t. That gives me t squared. Multiply t times 1/5. That gives me 1/5 t. Square the 1/5. So square the top and square the bottom. So that gives me 1 over 25. Same sign is a plus. All of these have been plus. Opposite is a minus. Always positive is a plus. You're not always going to have positives to have to do with these cubes. The next page. I'm not going to do another fraction one because we're really not going to encounter a lot of fractions. Let's do again. I don't know why. Oh, they're showing you the general way to do it. and you will not see my square multiply square way on the examples or in the videos that come straight from your book, because that's just something that I learned along the way. So you won't be seeing the same thing. They'll be talking about this formula to fill in. Alright, so for 8x cubed minus 27, I can't take out a GCF. So I'm going to do little, big, binomial, trinomial. 8x cubed is 2x. 27 is 3 times 3. Here we go. We're going to have a minus in this one. So we're going to do square, multiply, square. So I'm going to square 2x. That's going to give me 4x squared. I'm going to multiply 2x times 3. Seems like we did this one. 6x. And then I'm going to multiply, or square 3, give me 9. So this time my original sign was a minus, so a minus will go for same. Opposite this time will be plus. Always positive will be plus. That last sign is always positive. Alright, let's do one more of the cubes. 27b cubed minus 8. So can't take out a greatest common factor. I've got cubes, so I'm going to do binomial, trinomial. 27 is 3 times 3 times 3, and then b cubed is the b, and then the cube root of 8 is 2. So we're going to square, multiply, square. And so we get 3b, and we're going to square it. Don't forget to square the 3 and get a 9b squared. We're going to multiply them together. 3b times 2 is 6b. And we're going to square the 2. That gives me a 4. So same sign is negative. Opposite is positive. Always positive is positive. Alright, so here's our summary of factoring our binomials. You could either have the difference of squares, perfect squares. You could have the sum of squares, which remember, can't factor those for prime. We can have the sum of cubes, the difference of cubes. So let's just do a couple of these because these are going to be ones that are kind of mixed up. So let's try a few of these. Alright, if you've got x cubed minus y to the 6th, those are going to be cubes because I see an x cubed. So that's going to be cubes. So binomial, trinomial. X cubed is x times x times x. Y to the 6th is y squared times y squared times y squared. We're not going to see a lot of these, so I'm just going to work a couple of them. And so we're going to square, multiply, square. So I'm going to have an x and I'm going to square it. So x squared. I'm going to multiply x times y squared. So that's xy squared. And I'm going to square the y squared, which gives me y to the 4th. So then same sign would be negative. Opposite would be plus. Always positive would be plus. Let's go over and do this 98 minus 2t cubed, because remember, anytime we're factoring completely, we look for a greatest common factor, and I can take a 2 out of both of those. So I'm going to take a 2 out, and that's going to give me 49 minus t cubed. Now, if that were t squared, that'd be really great, because then I'd have perfect squares, because 49 is 7 times 7. But t cubed, 49 is not a perfect cube, so this would be my final answer. 49 is not a cube. Alright, let's do a factor completely at the bottom of the page. We've got b cubed minus 27. Let's do the one. These are factored completely. These are still just cubes, but it's got double letters in there. So let's do this one with double letters. I can't take out a greatest common factor, so we're going to do cubes. B cubed is b. 27c squared is going to be 3c. Okay, so having two variables in there makes this one a little bit different. So square, multiply, square. Notice I've written that every single time so I don't forget it. B squared is b squared. Multiply them together. B times 3c would just be 3bc. Put the 3 first. And then 3c squared would give me 9c squared. Same sign as minus. Opposite is plus, always positive is plus. And so there's one with two different variables. Okay, on the next page, we've done one like that where we've got the c squared, or where you can go further. I'll just do it one more time just to remind you. If I've got 16x to the fourth minus 1, again 16 is in a perfect square. X to the fourth is x squared times x squared, and then there's a minus sign in between them, so I know I can work it. So perfect squares, you get binomials in each one, and so this is going to be 4x squared, 4x squared, 1 is 1 times 1, we're going to add, we're going to subtract. And remember, if you'll remember from the section when we did perfect squares, you could look at 4x squared and 1, that could go further, because 4x is 2x times 2x. 1 is 1 times 1, 1's a plus and 1's a minus, and then the 4x squared plus 1 couldn't go any further because it's the sum of squares. So that's a little bit of a review on that one. Alright, so that's pretty much factoring our perfect cubes with a little bit of review on perfect squares. Y'all have a wonderful rest of your day.